Okay, here we have an application of Charles's law. How are we going to use Charles's law, and what is Charles's law? I teach this composite um, simple gas laws where we have P1 V1 over N1 T1 equals P2 V2 over N2 T2. If you have Charles's law memorized, you can go ahead and use it. You don't have to go my way at all. This just helps me remember them all because I don't remember them all the time. And so I look at the problem because I don't even, we're told that we're using Charles's law, but we don't always know that sometimes. And so we have, let's read the problem. We have a certain volume of helium gas inside of this balloon, and it's at 13 degrees C, so a little bit chilly out there. The balloon is then taken outside where the temperature goes way down below freezing. Calculate the new volume of the balloon. Well, we do know in this case that the number of moles don't change, so mathematically they will cancel out. And since it tells us what to assume the pressure is, so the pressure in both circumstances is going to be the same. And the leftover is Charles's law, where we have V1 T1 equals V2 T2. And as in almost all of these cases, I can't think of one that isn't the case. We're given three knowns and we have to solve for one unknown. So the volume of one is going to be 27.7. The temperature of one, we have to do these in degrees Kelvin. And so this is going to be 13 degrees C plus 273.15, and that will give us a temperature in degrees Kelvin of 286.15. I can see when I add here that my least precise number is going to be in the ones there with that 13. And so my sig figs are at that 286 in the ones. So I got V1, T1. I need V2. That's what I'm trying to solve for. And then T2 is going to equal minus 2 degrees C plus 273.15. And that's going to equal 271.15. Again with my sig figs here. So you can see that even though this looks like one sig fig, when you're doing your calculations, it turns out when we do the addition, we get 3 sig figs out of this because our least precise number is in the ones. Okay, let's just go ahead and then just solve the problem. So we are solving for V2, so V2 is going to equal V1 T2 over T1. I just did the algebra myself to make it easier when I plug things in. And so now I have V2 equals 27.7 times T2, which is 271.15. Remember those sig figs, divided by 286.15. And that's in liters, that's in degrees C, that's in degrees C, so those will cancel out in this math. And if I do this, let me get on my calculator and do this, I get 27.7 times 271.15 divided by 286.15. And that gives me that V2 equals 26.247. Okay, I need 3 sig figs. So I can say that my final volume for V2 equals 26.2 liters. All right, these are cake. Again, if you know Charles's law already, you don't need to do that at all. It just helps me remember. I can keep them all together. Make sure you get these to degrees Kelvin and make sure you get the right number of sig figs. It's always a little tricky because when we do division and multiplication, it is the number of sig figs is the number with the least number of sig figs in the factor. It took me a while to figure that out. So if we were just multiplying these directly, then you might think you only have one sig fig or two sig figs. But we're doing this addition and subtraction, and when you do that, that actually leaves us with three sig figs. So we'll have three sig figs in our answer. These are way doable, better than AI, except when I was struggling to get the sig fig definition out. I think you can do this. Be good.